since each function assigns elements of the domain with elements of the codomain, we can view this function as giving each element x a label y. Consider the following example. Your domain is a set of fruits in the supermarket, and the codomain the set of labels. With this example, the function is a labeling function, which assigns its fruit its corresponding label. But now, there are many types of functions that you construct between the domain and codomain. And so there is many types of labeling. So, our goal now is to classify, to understand what are these types of labeling for best and worst. So let's make a following spectrum. All the scenarios that you are going to find. The worst case scenario and the best case scenario. So consider the following two sets, the domain and codomain. Here's a set of fruits. So let's consider apple, banana, strawberry, and oranges, and the labels 1, 2, 3, and 4. A function will connect elements of these two sets. And so, what is the best? Let's consider the best possible labeling. The best possible labeling works like this. Each fruit has its own unique label. Note why this is the best. If you just focus on the fruits, you can distinguish them because they are different elements. But you now assign each fruit a label. Now let's focus on the labels. The labels are different, and so if you distinguish the labels, you are in turn distinguish the fruits because each fruit is assigned to a unique label. This is the best case of labeling. Let's see now the worst. You can already see what's the worst case. So we have again our fruit shop with apples, bananas, strawberries, and oranges, and our labels 1, 2, 3, and 4. The worst case will be every single fruit is assigned to a single label. Because now, if you focus on the fruits, well, you can distinguish them. They are different elements, but because our function maps each fruit to a label, in this case a single label, if you now focus on the single label, well, there is just one label. Imagine going to one shop and everything has a single label. How is the machine going to distinguish between what it's reading when you are about to pay? Well, you can no longer distinguish the thing. Okay? So this is the worst case scenario. Now, between the worst and the best, you can have somewhat the intermediate cases, which is, for example, well, it could be a shop that has apples and bananas labeled the same thing, while strawberries and oranges also another code, another label, 3. This time, distinguish the fruits just fine, but the machine, or just reading the codes, you can no longer distinguish all the fruits. Well, you cannot no longer distinguish, for example, between apples. The machine does not distinguish between apples and bananas, and does not distinguish strawberries from oranges, but at least with the codes or the labels that we have here, it can at least distinguish between these two and these two. So this is the intermediate case. And now, to make this thing more clear and rigorous, let's introduce some definitions. So, let's see the first definition, which says the following. F is onto, or should I say surjective, a surjective function. A surjective function is a function that uses all the labels, like in this case. So, but let's write this rigorously. So this is in English. Let's write now using logic. So it means that for every label y, there exists a fruit which is assigned to that y. So this thing, written in English, is an abbreviation for this thing. The second definition I want to give you is when we say that f, or the labeling function f, is 1 to 1. I think it's quite easy to see intuitively what this is supposed to mean. 1 to 1 simply means one fruit, one label. But using logic notation, how do we express this idea? So we simply say that for each pair of fruits, name it x1 and x2, if the fruits are different, then the labels assigned to each fx2 and fx1 are different. So this is the idea, the definition again. You can see it here, this function. Each two fruits are assigned to different labels. So in this case, you can already see immediately that that function is 1 to 1. Finally, let's see one more definition, which says that f is bijective. This is the ideal scenario, because being bijective means you are onto and also 1 to 1. Now, let's analyze this case in more detail. Because, once again, x and y are not variables for you to choose. These are bound variables. And we can see that by unpacking what this thing is supposed to mean. So this thing, in turn, means, remember, it's for all labels, this thing is true. And what is this thing? Well, there exists a fruit assigned to it. So let's write it like this. This thing here, let's unpack it here. So this thing is in turn equivalent to, well, for the first label, 1. So we write there exists a fruit which is assigned to 1. And because this is a for all labels, you want this thing to be true and this thing to be true. So that there exists a fruit assigned to 2, and there exists a fruit assigned to 3, and of course, finally, there exists a fruit assigned to the label 4. So this thing here can be unpacked into this thing here, a string of ends. In turn, what does it mean that there exists a fruit assigned to 1? This is in turn unpacked like this. So we either, the key is either or. Either f of apple is mapped into 1, or f of banana, so the label of banana is equal to 1, or the label of strawberry is equal to 1, or the label of orange is equal to 1. So this unique thing is now unpacked into this thing. And similarly, for these and these are just like this here, except instead of 1 is 2, 3, and 4. Now remember, x and y is not for you to choose. You can see that now, because this thing is unpacked into this thing. Well, there is no x or y here. It's just a string of ors. And in the same way, this is also a string of ors, and this one and this one. So there is no x or y for you to choose. However, let's look again more carefully. Is this true, or is this false? Is this statement true, or is this statement false? You need to specify f. F is your unknown. We still did not specify f. And depending upon the f that you choose, this may or not be true or false. So for example, consider f to be this function. So this is f. In order for this statement to be true for this specific f, it means that this thing is true, and this thing is true, and this thing is true, and this is true. In turn, for this thing to be true, either this is true, or this thing is true, or this thing is true, or this thing is true. So let's look and now analyze this thing and look at each one. For this function, is it true or is it false that the label of apple is 1? No, it's not. It's 2. What about banana? Is it 1? No. Strawberry is 1? No. What about oranges? Is the label 1? No. So it's false, 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 false. The entire thing is false. This thing is false. And because this thing is a string of ands, a single false one renders the entire thing false. So this statement is false for this particular f. Now, you can see, if you now consider this f, the same thing happens. There is nothing assigned to the label 1, so this is immediately false. Is there anything assigned to the label 2? Yes, there is. In fact, there is 2. Apples and bananas. We'll make this thing true. There exists 2 axes, 2 fruits assigned to 2. In this case, apples and bananas. What about the label 3? Is there any fruit assigned to 3? Yes, there is. Strawberries and oranges. We'll make this piece true. What about the last one? Is it true or is it false? No, there is nothing assigned to 4. So this is false. This is a string of ands, this is false. And because this thing is equivalent to this is false. And again, this function f is onto. No, it's not. It's false. Consider now the last function. This is f. I think this is quite easy now, once you get the idea. The thing is equivalent to this string. Well, apples is assigned to 1. That makes this thing true. Because this is a string of words, the entire thing is true. This is true. Is there a fruit assigned to 2? Yes, there is. Bananas. Is there a fruit assigned to 3? Yes, there is. Strawberries. And about 4, there is oranges. So this is true, 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 and true. This is a string of ands. It's also true. This is true. And so you can say that that function, the last one, the best case scenario, is a onto function. Again, you can view all this intuitively. You can just look at it and view intuitively. However, it's useful to be able not only to see intuitively, but also to being able to relate your intuition with what exactly this thing is supposed to mean. And what this thing is supposed to mean is written here after you unpack everything. Now, let's focus now on being one-to-one. Again, you can unpack this thing and analyze whether the truth value of this thing, just like we did here. Okay? I'm not going to do that in this lecture, and I'm going to leave it as an exercise. However, let's see intuitively instead whether this statement is either true or false. So, again, f is yet to be specified. So let's choose this f, not this one, but let's make f this function. So f is our unknown. Is this thing true or is this thing false here? Is it true for different fruits corresponds different labels? No, it's not. Everything has the same label. So for this f, this obviously not a one-to-one function. What about here? Is it true or not? No, it's false. You can see immediately. Apples and bananas have the same label too, not different labels. So this is false. Finally, you can see this is the case, the best scenario. Different fruits have different labels, just like shown here. So again, you can say that that function is one-to-one. Now, what about being bijective? Well, we can it immediately follows that it is bijective because we already seen that it's onto and one-to-one. So bijective functions are the ones that works best at labeling. Now, let's just summarize these ideas as follows. The main ideas are these. Functions are assigning elements between these two sets, and thus you can view them as a labeling. Functions can assign the elements of the sets in many different ways. And so there are many types and qualities. There are many qualities of labeling, ranging from best to worse. In order for us to classify how good this labeling is, we introduce these three definitions. And the definitions essentially says that f is onto means all labels are used. To say that f is one-to-one means, well, every label, every fruit has a unique label, and so there is no two fruits assigned to the same label. Okay, but however, there is a drawback. Saying that f is 1 to 1 guarantees that each fruit has its unique label. However, it does not guarantee that every single label is used. Analogously, f being onto guarantees that every single label is used, but it does not guarantee that each fruit has unique label. Finally, being bijective essentially says that not only all labels are used, each fruit is assigned to unique label. Okay? This is the main idea that we see here. And just to finish, I remind you again, in this statement, f is onto, f is 1 to 1, or f is bijective, f is the unknown. For some, this is true. For others, it's going to be false.